Alright guys, welcome to your first flipped homework. Today we're going to be talking about metals, nonmetals, and metalloids. So our central question is, what are the differences between metals, nonmetals, and metalloids? We have three main questions we're going to answer today. The first one is, where are the metals and nonmetals on the PT, periodic table? What are the properties of metals and nonmetals? And what are metalloids? Alright, first let's review the parts of the periodic table. On the left hand side you have your metals, and that covers all the green, including this area down here. And if you remember, that was just cut out of this little area right here, otherwise the periodic table would be extremely long. You have your nonmetals on mainly the right hand side, but you also have hydrogen over here, and don't forget that's also a nonmetal. And then you have metalloids down the stair step, and I like to call that the stair step because it's shaped like stairs. So review: metals, left hand side; nonmetals, right hand side, except hydrogen; and then metalloids along the staircase, except aluminum. We know aluminum is a metal. Okay, let's talk about some properties of metals. So first, there's solids at room temperature, meaning at room temperature 72, 73 degrees are solids, such as copper, mercury, gold. They have high luster, meaning they're shiny. Gold is shiny, silver is shiny, copper is shiny. They're malleable, and all malleable means is you can bend it into shape. So an example of that is these rings. This is copper. You can bend copper into shapes. It's ductile, meaning you can pull it into wire. Great example is shown over here also. You can pull copper into wire. And metals are a good conductor of heat and electricity, and that's something you should remember from 5th grade. Okay, let's talk about properties of nonmetals because they're the opposite. So there's a picture of bromine on the side. I was wondering if you've ever known what bromine looks like in liquid form. That's it. Oxygen, phosphorus, and sulfur. So let's talk about the properties. Most of the time they're gases at room temperature. They have low luster, meaning they're dull, they're not shiny. They're brittle, meaning easily broken. And they're poor conductors of heat and electricity. This is going to be really important to know the difference between metals and nonmetals on your lab this week, because you're going to have to determine whether or not something is a metal or a nonmetal. Alright, let's look at the periodic table again. So we've kind of talked about metals, mostly on the left. Talked about nonmetals, mostly on the right, except for our friend hydrogen. But now let's talk about metalloids. Metalloids are a unique combination. So here's one. This is silicone, if I could just get it enlarged here. This is silicone. Silicone's pretty unique because it shares properties of both. And you may not have ever known this, but if you have, that's great. Picture right here is an example of a circuit board on a computer. And if it wasn't for silicone, we would not have circuit boards. But remember something very important about these. These are located down the stair step, except for aluminum. Alright guys and girls, so your homework is to fill out your Venn diagram with the similarities and differences between metals and nonmetals. We will be reviewing this tomorrow to help you start understanding the differences between these two, metals and nonmetals. Have a great night, and I will see you tomorrow when you get into class. Bye-bye.